In this lesson, I'll show you two examples on how to find the equation of a plane in 3D space. Question 1 reads, find an equation of the plane through the point 2, 4, and 1 with the normal vector n with the x, y, and z components shown there, and find the intercepts and sketch the plane. Before we start this, I want to go through some important theory, and this will help you understand why we're doing what we're doing here. The equation of a plane in 3D space is determined by two things: a point and a vector n known as the normal vector. And this vector is at right angle to the plane. The equation that you use if you have this point and the vector n is shown right here, and that's what we'll use for question 1. This formula is derived by taking the dot product of n and the difference vector of a point along the plane minus the initial point p. Think of 2 points in 3D space along a plane. Subtracting their coordinates gives you a third point, and that third point can be shown as a vector. Taking the dot product of that with n gives you this formula. Now with that said, going back to the question, we want to find an equation where the point is 2, 4, and 1. So wherever you see x sub 0, y sub 0, and z sub 0, you replace it with 2, 4, and 1. In addition, each component of the normal vector 2, 3, and 4 will be a, b, and c respectively. So all we have to do is remember that this is a, that's b, and that's c. Replacing these into our equation, we have 2 bracket x minus 2 plus 3 bracket y minus 4 plus 4 bracket z minus 1 is equal to 0. Now of course we can expand this, and that will probably help us with the next part where we have to find the intercepts. You can find the x, y, and z intercepts of a plane by, let's say if we want the x-intercept, we set y is equal to 0 and z is equal to 0. So if I expand this, I should end up with 2x minus 4 plus 3y minus 12 plus 4z minus 4. I will combine these three terms. Minus 4 minus 4 minus 12 is minus 20. So I have 2x plus 3y plus 4z minus 20, and I'll bring that over. We end up with equals to 20. So if I substitute y is equal to 0 and z is equal to 0 into here, that becomes 0, that becomes 0, and we end up with x is equal to 20 divided by 2, that's 10. We have a point that is at 10, 0, and 0. That right there is the x-intercept. If we want to find the y-intercept, we set x is equal to 0 and z is equal to 0. And lastly, if you want to find the z-intercept, you set x and y equal to 0. And if you do that correctly, you should end up with the 3 points. Now we can plot this on an x, y, z plane. And here I have just that. This is z, this is x, and this is y. Plotting this, we have 10, 0, and 0. So we can place that right here. Y would be at 0, 20 over 3, and 0. 20 over 3 is approximately 6 point something. So that would be around here. And this point would be up here. Connecting these through straight lines, we should get something that looks like this. And notice that we've only drawn the plane within the first octant. And that's fine. That's the answer to question number 1. In question number 2, we're asked, find an equation of the plane that passes through the points P, Q, and R. This one's a little more involved. So we have 3 points that are on this plane. And what we want to do first is generate 2 vectors using these 3 points. So I'll generate a vector PQ and a vector PR. Starting with this vector, and for simplicity I'll just call it A. I can find this by subtracting 3 minus 1. That's 2, minus 1, minus 3, that's negative 4, and 6 minus 2 is positive 4. I'll call this one B. 5 minus 1, that's 4, 2 minus 3, negative 1, and negative 2. So I have 2 vectors here, and what I'll do next is find the cross product of these 2 vectors, because by finding the cross product of any 2 vectors, you're actually finding a third vector that is at right angle to both of them. So I'll take the cross product of A times B And this can easily be done by rewriting this twice. So 2, -4, and 4, 2, -4, and 4. And this one, 4, -1, -2, 4, -1, -2. By remembering this pattern, -4 times -2, that's +8, minus the product of these two. So +8 plus, because that's negative, 4 is 12. Similarly, 4 times 4 is 16, minus -4, that's +20. And 2 times -1, that's -2, minus -16, that's equal to +14. So now we have the cross product of A and B. And now using, once again, this formula that was provided here with the point P, we can write down the formula again. So we have 12 bracket x minus z sub 0. So x minus, we have the coordinates 1, 3, and 2, so that's 1, plus 20 y minus 3 plus 14 z minus 2. And that's equal to 0. So you can record it like this or expand it to simplify, but it doesn't really matter. And there you have it. That is how to find the equation of a plane in 3D space.